All right, so in this video, I'm going to work through problem set 3-7. In question one, we're trying to find the length and width of a rectangle with perimeter 80 and maximum area. So if it has perimeter 80, let's call this side X and this side Y. That's going to tell us that 2X plus 2Y equals 80. And we're trying to maximize, or let me first write Y in terms of X, right? So if 2x plus 2y equals 80, that means y equals 40 minus x. And we're trying to maximize f of x equals xy, right? The area. And that is also equal to x times 40 minus x, which equals 40x minus x squared. Okay, so we're trying to maximize this. That means we want to find the critical points. So we'll find the derivative and set it equal to 0. Derivative is 40 minus 2x. I'm trying to set this equal to 0, which means that x will equal 20. Okay, now we want to check that this is a maximum, and we'll do so using the second derivative test. So to find the second derivative is going to be negative 2. And so that tells us that x equals 20 is a maximum. Right? Because anytime we have a concave down, the critical point will be a maximum. Okay, so once we've found x equals 20, what remains is that we're going to want to find the other side length, which is going to be 40 minus 20, which is 20. So our final answer, the length and width are both going to be 20. Question 2, find the length and width with the area 49 and minimum perimeter. I think this was on the classwork, wasn't it? So a rectangle XY, we're given that the area is 49. So let's try to get this in terms of one variable. So y equals 49 over x. So we'll make that substitution. And we're trying to minimize f of x equals the perimeter, which is 2x plus 2y. And so if we make the substitution, y equals 49 over x, this will be 2x plus 98 over x. Right? Then finding the derivative, we're going to get 2 minus 98 over x squared. And we're looking for critical points, so we'll set that equal to 0. Move things around. It's wrong. X squared equals 49, so x equals 7. All right, we don't care about negative 7. All right, then if x equals 7, then y equals 49 divided by 7, which is also 7. So that's going to be our answer, 7 comma 7. We also need to do the second derivative test to check that this is a minimum. So the second derivative will be 98. All right. Second derivative is 196 over x cubed. Like, I might have done that wrong in the lecture. I don't know, did I? Anyways, the second derivative is 196 over x cubed. And when we evaluate that at the critical point, right, that means the second derivative at x equals 7, 196 over 7 cubed, which is greater than 0. So that confirms that x equals 7 is a minimum. Next question, number 3. A farmer plans to fence a rectangular pasture that's adjacent to a river. So we have y, and x. The pasture has to contain 2 square miles. Okay, and we have a three-sided enclosure. So we're given a constraint that xy equals 2, because that's the area of the enclosure. Okay, so that means that y equals 2 over x. But now, what are we trying to maximize? We're trying to minimize least amount of fencing, right? So we're trying to minimize f of x equals x plus 2y. That's the amount of fencing. And x plus 2y is going to equal x plus 4 over x. So to minimize that, we'll take the derivative and find the critical points. The derivative will be 1 minus 4 over x squared. Okay. And to set that equal to 0, we'll find the critical points. 1 equals 4 over x squared equals 4, x equals 2. And if x equals 2, then that means y equals 1, because y is 2 over x. Lastly, we need to check that this is a minimum. The second derivative of f is 8 over x cubed. So that means the second derivative at the critical point is 8 over 8, which is 1, which is greater than 0. And so x equals 2 is a minimum, because we have a concave up situation. Number 4, a Norman window. Never heard of this thing? A semicircle on top of a ordinary rectangular window. Okay, we're given some labels there as well. The height is going to be y here, and the width is x. So that's going to tell us that the radius r is x over 2, right? Okay, find the dimensions with maximum area when the total perimeter is 16 feet. Okay, so what is the total perimeter? Well, the perimeter of the square section, sorry, of the rectangle section is x plus 2y, right? Because we have this side, and this side, x plus 2y. Now the perimeter of the semicircle section is going to be pi x over 2, right? Why is it pi x over 2? Well, the perimeter of a circle is 2 pi r, right? So the perimeter of a semicircle must be pi r. And based on this diagram, we know that the radius r is x over 2. Okay. The total perimeter is 16 feet. So we know that x plus 2y plus pi x over 2 is equal to 16. Okay. Um, yep. So now it's probably going to be helpful to try and rewrite y in terms of x. So we'll try to isolate y. This is going to be 2y equals 16 minus x minus pi x over 2, or pi over 2x. Which means that y equals, what's the simplest way to write this? 8 minus 2 plus pi over 4x. Okay. Right now, what are we trying to maximize? We're trying to maximize the area. The area is the area of the rectangle, which is xy, plus the area of the semicircle, which is 1/2 pi r squared, right? So it's 1/2 pi r squared. Now we can plug things in. X times y plus pi over 8x squared. Right? So expanding this a little more is going to give us 8x plus pi over 8 minus 2 plus pi over 4 x squared, I believe. I can simplify that a little more. Okay. And we're going to set this equal to 0. So after we set this equal to 0, we can solve. We're going to get 8x equals pi plus 4 over 8. Well, let me be more clear. We're going to get a solution of 0 because we can also factor this, right? We can factor out x. We'll be left with 8 minus pi plus 4 over 8x equals 0. And so we're going to throw out the x equals 0 solution because that doesn't make sense physically. So we're left with 8 minus pi plus 4 over 8x, or we'll just say 8 equals pi plus 4 over 8x, which means that x equals 64 over pi plus 4. Okay, and that'll be our critical point. We also want to check that, okay, let's first solve for y. So y is going to equal 8 minus 2 plus pi over 4 times x. And that'll give us 4 cancels out with 64, gives us 16. If we reduce this to a single fraction, 8 pi plus 32 minus 16 pi minus 32 pi plus 4. Which will give us, oh no, a negative number. Jeez, there's something wrong? 8 minus 2 pi. Hmm. Yeah, honestly, I don't see my mistake. Hmm, interesting. Seems like it's outside the domain. It's really weird. It's too big. X be 9. Doesn't make sense at all. It couldn't be 0 either. Is y just equal to 0? Yeah, I keep simplifying. Y is going to be negative. Oh my gosh. Finally found my mistake. I didn't even differentiate this. I'm so such a foolish mistake. Okay, ignore everything. Gosh. Forgot to differentiate the function. Right? Jeez. This is really dumb. Okay. I forgot to differentiate it, right? I have to differentiate the function in order to set it equal to 0. Oh my gosh. What am I doing? Okay, let me keep simplifying this. 8x minus y plus 4 over 8 x squared. Yeah. And then if I differentiate it, I get 8 minus y plus 4 over 4x. And now I can set it equal to 0. So I have pi plus 4 over 4x equals 8. So x is equal to 32 over pi plus 4. Now if I plug it in, I get y equals 8 minus 2 plus pi over 4 times x, which is 32 times pi plus 4. And so this is going to give me 8 minus 8 times 2 plus pi over pi plus 4, which gives me 8 pi plus 32 minus 16 minus 8 pi over pi plus 4, which is equal to 16 over pi plus 4. There we go. That makes sense. Okay. Now, now I want to take the second derivative just to check. And so finding the second derivative, here's my first derivative. So to find the second derivative, that's just going to be negative pi plus 4 over 4, which is less than 0. So we have a maximum. Okay. That was scary. I thought I was losing my mind. Question 5, I told you guys to skip it. Let's do question 6. We're also skipping 7, right? So a cylindrical package is to be sent by postal service. Cylinder. Let's call it R and H. Or I'll say L, right? Like length. It can have a maximum combined length and circumference of 108 inches. That means L plus the circumference, which is 2 pi r, correct? L plus 2 pi r is 108. We're trying to maximize the dimensions of the maximize the volume. Okay. So let's first write L in terms of R. L equals 108 minus 2 pi r. Trying to maximize. You could have used different letters, obviously. We're trying to maximize f of r equals the volume, which is pi r squared L. All right, area times height. Pi r squared times 108 minus 2 pi r, which equals 108 pi r squared minus 2 pi squared r cubed. So we take the derivative, which will give us 216 pi r minus 6 pi squared r squared. I'm going to set that equal to 0. Let's factor it first. Factor out r, 16 pi minus 6 pi squared r. Obviously, r can't be 0. That will not be a very nice package. So we're looking for 216 pi minus, or 216 pi equals 6 pi squared r, which tells us that r equals 216 pi over 6 pi squared equals 36 over pi. Okay, that will mean that L equals 108 minus 2 pi r, 108 minus 2 pi times 36 over pi, which is 108 minus 72, which is 36. Great. Finally, as a last step, we want to check the second derivative, make sure that this is a maximum. And so the second derivative, we'll differentiate that. That's going to give us 216 pi minus 12 pi squared r. So we plug in r equals 36 over pi. We'll get 216 pi minus 12 pi squared, 36 over pi, which is equal to 144 times 3 is 432, I think. 432, 216 minus 432 is 216. Okay. So that's the second derivative at that critical point, 36 over pi. So yeah, it's a negative second derivative. So concave down, maximum. All right.